Hi, hello and welcome back to my channel Java with Ali. And if you don't know, I am Ali. So today we are going to talk about insertion sort, and it is video 4 of the upper intermediate series. So if you haven't subscribed, please like, share and subscribe, and I'll keep making more. So we're going to have a look at insertion sort now. It is the same efficiency as selection sort. So the difference between selection sort and insertion sort is very easy. Selection sort, you select the smallest number and you bring it to the top, and so on and so forth, like I explained in the previous video. Insertion sort is when you insert it. So it's the same efficiency, and we're going to cover a more efficient sorting method in the next video, which is going to be merge sort, but for now we're going to stick with these. So what we're looking at here is I also have put main at the top so that it's easier to read, because that is the main entry point of the program in the main thread, and we're going to walk through the program and then I'm going to explain insertion sort when we get to the right section. So here we have import java.security.secure random. So we're importing the packages, and we're importing secure random, and we're importing arrays as well, because we're going to use it as part of the collections framework. If you're unsure about collections, please check out my videos. So insertion sort test then, as per usual, class name starts with a capital letter, and then we have our main method. So like an onion, like I explained in the previous video, here's an onion, it's got layers. The outer layer is the class, inner as you go in, you've got methods to do with the class. So we have our main here, and we've created a new object of secure random, and it is called generate random numbers, and we are going to use Java 8 functionality in this program as well as the previous program, and we're going to use int streams. So we have our int stream here where we have 10 items going from 1 to 10, and it's, so if we read it the other way, like I like to do, so we are converting something to an array. We're passing through some parameters into an int stream, so we've got numbers from 1 to 10, 10 items of ints, and it's part of the generate random numbers object. So that's number one thing. So, and then we obviously assign it to data, which is an int array. So now we have an array with 10 elements in it, index from 0 to 9, but the length is 10. Index 0 to 9. Remember this. Index is different to length, like I repeat all the time. So we have data, we've got 10 little boxes, and random numbers from 1 to 10 in each of those. And it's an int stream, so it has, each of those are now random. Now we are printing out, the first thing that we do is print out the unsorted array. So the before picture, I copied it directly from the previous program because it was pretty much the same. And I'll post these as well up on GitHub once the video is released. Then we have our toString, which we convert arrays.toString data. Why do we do that? Because we need to convert the int array into a string, so it will output a string on screen. Otherwise, you're going to get some gobbledygook. Okay, next then we call a method called insertion sort, and we pass through our array. So when we pass through our array, obviously we're going to do something to it. So that is the next method. So I'm going to jump down here. This method isn't closed yet. This is still open if you're unsure about stacks and things like that. This is still an open method, so it's still running in the background. It's still open until there's a return call from insertion sort back, and then it finishes this program. So here we have insertion sort. We pass through our data array. Our first thing that we do is going to be a for loop. We have int next is equal to 1, next is less than data length -1. Why is that? Because the array is always less than the index. And if we were to go and remove the -1, what would we do? What would happen? Array index out of bounds, perhaps. And then next plus plus. So here we have whatever is here loop wise. So we have 10 items, 1 to 10, goes in here, is inserted the first time into a variable called insert. Then next is also going to be inserted into move item. So whichever, like it's going to go 1, 2, 3, 4, and so on and so forth. Now we have, so this is the value to insert here. Obviously it's called insert. This is why we give things meaningful variable names. It's really important in industry, especially when some other programmer comes along and looks at your code. So the next thing then is next equals move item. So this would be our variable from our loop. So obviously it's going to be 1 to 10. So we're going to move the item 1 to 10 places. So search for place to put current element, and that's where your while loop comes in. So move item less than is greater than 0, and this is very important because we have our conditional operators, and here it's the same as our logic gates, which I should really do a video on logic gates. If you would like to see it, please comment below and I will do a video on the 7 logic gates that are so important and exclusive or etc. They're really important. They come from electronic engineering. If you haven't taken a course in fundamentals of electronic engineering, then basically the circuits go on and off because everything goes back down to binary, eventually to ones and zeros. That's a really simplified version, but you get the idea. So it's all part of processing power, etc., hardware, etc. Without going into too much detail because we need to get through this topic. So here we have this then, data move item -1. So we say item is -1 is greater than insert. Okay. Then, so this is just more of our condition here. So our insert here is actually taking 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? But it has to be less than move item -1 has to be less than that. So it basically is the condition going through it. So it shifts the element then right y1 slot is here, and then it de-increments. So this is our incrementation, so it's going 1 to 10. This is our decrementation, so it's going the other way. Then we have our insert is now going to, so if you see here, insert is used 1, 2, 3 times here, where they're highlighted, here and here, and it's going to be allocated to move item is also, so place inserted element. This is going to be place inserted element. Okay, now the method is still open. It's still going to run because now we call another method. So this is just our print pass, which is going to print out the stuff. If you're unsure about this code, please check out the previous video because I've already walked through this code. So I'm just going to run it and then you can see what is done. It's taking a while. So here we have our sorted array. So the picture before 7, 5, 5, 3, 5, 5, 1, 6, 7, 4. Then after the first pass, so we have 5, then 5, then 3. So what's actually happening is the really big part of this. So insertion sort, like I said, is this is kind of a funny one to explain. So it's inefficient again. The first element of the algorithm takes the second element in here. So here's the first element 7, takes the second element 5, swaps it. But we don't say swap because it's insertion sort, we're going to say insert. So it actually creates a temporary variable in the background. So we have our temporary variable that swaps it out. So we have the first iteration of the algorithm takes the second element in the array, which is 5. And if it's less than the first element, then swaps it with the first element, which it is. So it's swapped it. And then the second iteration looks at the third element and inserts it into the correct position with respect to the first 2. So all 3 elements are in order. So you can see here it iterating through. So as this is 7, 5, 5, here is my 5 because it swapped these 2. This one now gets swapped because this is now needs to be in order. 3 is going to be our next candidate. So 3 now gets swapped with all of these because we already calculated that it's less than, okay? Now we come on to the next, which is 7, which, oh my God, there's another 5. There's 4, 5. Maybe I'll run the program again so you can see it a bit better. Where you get the idea with this, and then we might run the program one more time with larger amount, let's say 1 to 100. Still stick with, let's stick with 5 items so it's easier to explain it better. This is a lot easier. So 265. So 65 is going to be swapped with 2 because the first element is, well, it's not going to be swapped because the first element is smaller than 65, so it's going to stay. Then 57 is going to be compared to 65, so it swaps it. Then 80 is going to be compared to 65 because these 3 are already in order, swaps it. It doesn't need to swap even because it's already the right size. And then eventually 58 is now going to be swapped with 80 compared to 80, compared to 65, and then 257, 65, 80, 58. So it's inefficient and that's not the right answer. Hang on a second. The after needs to print out 1 minute. I'm going to pause video and check my code because it should be the same. Hello. Okay, I ran the program again. I looked at the code and I did exactly what normally is. This is 0 and this is data length -1, but we do not need the -1 in this instance because it's going from 1, not from 0. So if I have a look then at the console again, here we go. So we have 2 is in the correct position because it's the lowest number. 73 is then compared to 2. Okay, that's great. It's still in the right position the first pass. The second is these 2 are compared and shifted over here. Then the next, etc., etc. And now we get the correct input. So that is insertion sort. Selection sort was selecting the smallest and going through. Insertion sort is inserting back into the array. So part of knowing about selection sort and insertion sort is the efficiency, because we don't want to be spending all day looking for this. So nested loops, when we have a for loop and a while loop, we have nested loops. They mean that you must multiply the number of comparisons. So they're both in selection sort and in insertion sort, both have nested loops and you have to multiply the comparisons. So it means that it's big O of O to the order n squared, which are both inefficient. And that's it for insertion sort. So if you have any questions, please comment below. Hope you liked the video. If you have, please like, share and subscribe. I'm going to put up merge sort next. And thank you for watching and thank you for subscribing to all the subscribers. Thank you. Okay, bye.